Many people, instead of thinking about a problem, just attack the problem, get into a mess, waste a lot of time, and then think about how easily they could have solved the same problem should they have thought about it earlier on. Here lies an important point. Before you start solving a problem, give it a couple of seconds, think about how exactly you're going to proceed with it, and then go on to attack your problem and find your solution. Let's go on to integration. Definite integration. A definite integration also requires you to keep in mind the various transformational properties. The objective approach here would be to estimate the value of the integral by taking maximum value of the function, the minimum value of the function, and eliminating options from there onwards. Indefinite integration requires you to have a thoroughly memorized standard format. Indefinite integration would require you to mug up certain formulae, mug up certain functions and what they would give once integrated. In non-standard questions, the approach is to look for substitutions such as trigonometric substitutions or logarithmic substitutions, and or say applying integration by parts when a beneficial outcome can be foreseen. The key point again, before you attack the problem, look for what exactly you're going to apply, make a plan and then attack the problem. The reverse differentiation can also be used as an objective approach wherever feasible. Now, as usually is the case in integral calculus, differential equations also demand memorization of the various type of standard differential equations. At the most, questions may involve some substitutions, after which the given differential equation transforms into a standard one. So, common errors people make while doing calculus problems. Often while using substitution in integration, students make the mistake in changing the limits of the problem. That is something you need to be very careful about. Again, remember that the necessary conditions for all the formulae that you are using are very important and they should not be overlooked. In questions of limits, always check both the left and the right hand limit and see whether or not they are equal. Check for differentiability, check for continuity. While finding the derivatives of some strange, weird looking functions, apply the first principles of finding derivatives. Don't rely solely on direct differentiation. Let's go on to the third component of JEE mathematics, that is vectors and three-dimensional geometry. Now, what's the scope of vectors and three-dimensional geometry in JEE mathematics? These are considered to be the most widely tested topics in the joint entrance examination. Bear in mind that these have been introduced rather recently into the NCERT syllabus and into the JEE syllabus as well. Vector mathematics coming in sometime in the last 8 years or 10 years. Now, the questions of vectors and 3D are not very difficult as such. What you would do well to acquire is a good sense of 3D imagination, a good sense of what skew lines are, a good sense of how figures look like in 3D. Your ellipsoids, spheroids and the like and such figures in 3 dimensions, if you can visualize, will end up saving you a lot of time. Then again, you use quite a few approaches in coordinate geometry and you can use quite a few fundamentals from your basic class 10th geometry which can help you out here. How is that? For example, in circles, you have the idea of subtension of angles from the same arc and such angles tend to be equal. Such ideas and the like can be applied very well to your 3D geometry and to 3D figures. Of course, that would require a bit of practice and some consideration, but that should be your major goal while practicing solving problems for JEE. You need to focus on solving such problems in a short period of time. And again, vectors and three-dimensional geometry is actually one of those topics for which you can develop a feel for the problem. And once you get that feel of the problem, you can solve problems in this much time. So the questions in vectors and three-dimensional geometry are usually solvable and involve very basic concepts and would just require a bit of extra thinking. It's not as if these questions are something which you would sit down with for days and days and you won't get these. The point again remains that you have to cut down the 10 minutes that you take to solve a problem to 1 minute. There's nothing else to it. The problems are very simple. You just need to develop that certain problem-solving frame of mind to solve problems related to vectors and three-dimensional geometry. Of course, these ideas can be very useful to you in JEE physics, in kinematics especially, and even in rotational mechanics. So make sure that this one topic of yours is done pretty well. If it is, 12% of marks in your JEE mathematics are a given. Now again, let us focus a bit on problem-solving strategies for vectors and three-dimensional geometry. So mostly problems are solved if you remember all the different formats of writing a plane or a line. If you remember certain very basic aspects that two planes will necessarily intersect in a straight line, two spheres will intersect in a circle, and so on and so forth. Here again, you can apply your very basic ideas of 2D coordinate geometry and solve the problems even faster. Think about how you would apply those formulae to these situations whenever you are practicing for such questions. Getting back to the line bit, whenever you have lines, for example, you could either go on to the standard formats of how to write a lines equation, or even better, you could assume your unknown to be a vector of the form of ai cap plus bj cap plus ck cap and proceeding. This is something that will be immensely helpful to you if you can juggle between various approaches and choose the optimum approach before starting to solve a problem. Again, note that you should not directly attack a problem. Think before a problem for 5 seconds or so and think about which strategy would be the best to attack the problem at hand. In vectors and 3D, like I said, you can develop a very basic feel for your problem. So what do I mean by this basic feel? Keep in mind the physical interpretation of the various formulae. It significantly reduces the length of tedious problems. Vectors and 3D is not like algebra where you have to do a problem from start to finish in a certain fashion. You can develop shortcuts. You can get from 1, 2 to the answer in moments if you have this basic feel for the problem. For example, cross products of two vectors represents the area contained in them, and a dot product is a projection of one vector onto the other. Such ideas need to be fixed in your mind. Your maths and physics will benefit greatly if you have a feel for vectors and 3D. Enhancing your ability to think in 3 dimensions is again important. It helps you visualize all the problems you solve. So when you start out to solve such problems, it is often a good idea to actually try and make stick models, to try and actually picture it with your fingers or something of this sort as to how exactly the problem will pan out. Again, a very basic point.